Hi everybody, this video is going to cover lesson 6.7, which is covering discontinuities. And we talk about discontinuities, we're mainly talking about two things, wholes and vertical asymptotes. Those are our two options for discontinuities. This video is going to go much faster if we go ahead and factor these four functions first. So if you will notice on your page there are four functions. I want you to stop the video here, pause the video, and go ahead and factor these four functions. So there's 1, 2, and then here is 3 and 4. So pause the video here, factor those, and then come back when you're done factoring. Okay, so you should have factored these four. And as we take a look at these, question A on each one says, before you cross out any factors, where does it appear the graph is undefined? So we've been looking at the denominator, and we look at that denominator, we say, okay, well, x plus 4 would give us a discontinuity at x equals negative 4, and x minus 1 would give us a discontinuity at x equals positive 1. The next question is, do any of those factors cancel? Well, yes, actually, x plus 4 does cancel, so the x plus 4 cancels, or in other words, the x equals negative 4 gets canceled. Okay, we're going to do that same thing for all three of these. Let's take a look at number 2. Where does it appear it is undefined? There are 3 of them. One of them is at 0. That's what this first one is. The next one is at negative 4, and the final one is at positive 4. Now, do any of them cancel? Well, let's see. Yes, this x minus 4 does cancel, so that means that x equals 4, or x minus 4 does cancel. The other one is this x and this x also cancel. Now that negative stays there, so you have to make sure you don't drop the negative off, but the x's also cancel, and that was what was giving me that x equals 0, so those are gone. Same thing on number 3. Where does it appear to be undefined? We look at the denominator, negative 3 and positive 1, but the x plus 3 cancels out, so that means the negative 3 is no longer part of that function, part of the graph. It will be part of the graph, but it's no longer there for now. All right, and then the last one, same thing. The denominator tells us x cannot be 0, x cannot be negative 2, and x cannot be positive 1, and that's a negative 2. And what cancels? This x and this x do cancel, so that one is gone. Okay, that's how we decide what are the discontinuities. The discontinuities are anything that makes the denominator equal to 0. We found those, but yet some of them cancel. So what happens when we cancel? And we talked about this a little bit before break, so we kind of know the answer to that. But let's just go ahead and finish this out. Back to the top of the page, it says do this column first. We did it. Do this column last. That's what we're doing now. All right, we want to enter this into either Desmos or your graphing calculator. I'm going to show you both of them, and you can see what they look like. So go ahead and get out your calculator and also start a new tab and go into Desmos. All right, I'm going to start here in Desmos. So here is my function. Here's what it looks like. And x equals 1 is here. I made it a dotted line so that you could see it. I'll show you what I entered. So when I entered this is the equation, the function that shows up in number 1. And I went ahead and entered this, and I made it a dotted line. The way I make it a dotted line is I go to the settings, and you click on it, and you say that you want it dotted. All right, so I have that there, and so now we can see x equals 1 is one of the vertical asymptotes. And that was listed on our discontinuities, and that one actually did not get crossed off, did it? Okay, that's important to note. The other discontinuity was negative 4. If we look at our graph, it doesn't look like we have anything missing on negative 4. However, if you click on it and drag the dot that you're able to drag and drag it down to the negative 4, it pops up as undefined. And did you notice how when we were over here, it's a solid dot, but then we would come and get on top of it? Now it's an open dot, kind of a hollow space there. That is a hole. So there is a hole at negative 4. So again, to find that on Desmos, I put in the function. I went ahead and put in the vertical asymptote. You actually don't have to do that, but I just wanted you to see where it is. And then if you needed to find anything or double check anything, you can drag along and see that that is undefined. Let's take a look now at your calculator. So in the y equals, I went ahead and made a fraction, and I put in my function. I'm going to go down one. Remember, to make a fraction, you go to the alpha and then the y equals, and that will give you, and then you hit enter, and that will give you a fraction. So that's how we do that. I entered the function just as it is. To do x to the third, you just do x and then caret and then 3. That's x to the third, and you have to arrow off of it. Okay, I'm going to delete that also because I don't need that. Now, when I go to my graph, I'm going to see what the graph looks like. So I'm going to go to Zoom Standard. Zoom 6 is my Zoom Standard, and it's going to graph mine. Now, the TI-83s cannot, or 84s cannot graph vertical lines, so I can't show you that x equals negative or x equals positive 1, but you can see where it would be, right? I mean, you can imagine that there is going to be a vertical asymptote there, but you can't, there's no way to do it on our calculators. Then, how about the whole? Well, we decided it was at 4, right? Okay, let's go to Zoom and go to decimal, Zoom 4, Zoom decimal. We go to Zoom 4, aha, look, it's tiny. Can you even see it? It's just a little gap on your calculator. And mine over here is so small you could barely see it, but over here I can see it, and so I do see it here. I'm going to show you also my table. Right now I don't like how my table is set up, so I'm going to, it says press plus for change in table. So actually let me go into the table first. I'm going to go into table. Second table. Here's my table. And then again, it says press plus for change in table. So I'm going to press plus, and I want to change by just 1, not 0.2, not anything weird, just 1. And I hit enter. Okay. My calculator is set up somehow to have the fractions over here, but that's okay. X equals 1 became an error. Why is that an error at x equals 1? Because we had a vertical asymptote, right? All right, if I arrow down, sorry, going the wrong way. I need to arrow up to -4, don't I? So I'm going to arrow up to -4. And at -4, I also have an error. That is because there is a hole. All right. So your calculator, you can look at your table. Wherever it says an error, it either needs to be a vertical asymptote or a hole. And to see that hole, you go to Zoom Stat or Zoom Decimal, and Zoom Decimal will give you the hole on your calculator. Okay, let's go back to our paper. Okay, so for this problem, we did enter it, we looked at it, we looked at the discontinuities. It says look at the table, look for the undefined values or error. So we just might make a note to ourselves that on the table we are looking for the word error. And that would denote a discontinuity, which ones are holes and which ones are vertical asymptotes. In this case, x equals -4 was a hole, but x equals 1 was a vertical asymptote. Okay, now we want to look at all 4 of these. So we're going to take a look at each of these. I have them on Desmos. I don't have them all on my calculator, but we can look at them on Desmos. It would probably be good for you to put them into your calculator so you have some practice with that. Okay, here is number 2. Number 2, again, I have shown a vertical line as a dotted line. I have the rest of it shown in the graph. And as far as what canceled on this one, the -4 and the 0 both canceled, didn't they? So let's go to 0, and there it was for a second. It's kind of hard to grab it sometimes. There it was. So that's the 0 undefined. That means there is a hole there on the graph. And when we draw it just like they're showing it here. Where'd it go? Come on, little guy. It's hard to get sometimes. There we go. That's how we draw it. We draw it like, I can't move off of it. We draw it just like that. We draw it like the curve goes, and then there's a hole, a circle there, and then we go on. Okay, our other hole was at +4. So if I drag over here, again, I have an undefined value there at +4. So this is a line that has a couple of holes in it. All right, that's number 2. Here's number 3. We still have our vertical asymptote at x equals 1, and the -3 should have a hole, so I'm going to go up there and drag and see my undefined there. I will also show you in the table. In Desmos, to do a table, you go again to the settings, that kind of that cogwheel there, and click on this, and notice it says +1 is undefined, and so that tells me that that is a hole there. Okay, so that's how you find your table in Desmos. I'm going to go back, but to do it again, we click on it, we go to the settings wheel, and we click on the table, and we have the undefined value there. And I'm going to go back to get out of it. And then the last one is here. This is, I appear to be missing another vertical asymptote, don't I? This is the, oh, here it is. This is the last one. And so it has a vertical asymptote at -2 and a +1. And then the whole, which canceled out, should be at 0. So if I go over here and drag, I do see a 0 there. Or if I go to the table, I should see my 0 or my undefined value. There's a couple of them. -2 is undefined because that's a vertical asymptote. 0 is undefined because that's a whole, and +1 is undefined because that's an asymptote. So back to our paper again, just to wrap up. Okay, so on number 2, we had a whole at 0 and 4 because those are the ones that canceled out. And we had a vertical asymptote at, I wrote 1, that should be a -4. X equals -4 because that's one that's remaining. That's the only one that's left there. That is still a vertical asymptote. Number 3, similar. I crossed out my 3's, so that means that left a whole. What's still there is the 1, so that is still a vertical asymptote. Okay, on number 4, I have a whole at 0 because that's what canceled. I have a vertical asymptote at -2 and +1. So the main thing that you need to take away from this is, let's go to the top. Discontinuities, they always come from the denominator, where the denominator cannot be equal to 0. So whatever would make it equal to 0 would create a discontinuity. Wholes are what cancel out, and asymptotes are what remain. And that's how we find wholes and vertical asymptotes on rational functions.